Okay, so we're going to look at systems of equations in three variables, x, y, and z. Now I'm going to do this first one because this is the basic one just to show you how it works, all right? So, okay, I can take a look at this and I go, well, I already know that z equals -4, okay? If z equals -4, well, I can plug it into here and I will have this for the second equation. 5y, 5 times -4 is -20, equals -30, okay? Add 20 to both sides. Divide by 5, y equals -2. Great, I've got y equals. So I've got z equals and y equals already. If that's the case, plug them back in to the first equation. Right, x plus, right, 3y, y is -2. For z, oops, z is -4, and that equals -17. So x minus 6 minus 16 equals -17. X minus 22 equals -17. X equals 5, okay? There you go, x, y, and z. Now I already had what z equals, and so that made it fairly straightforward, but that's the idea behind a lot of this. Let's take a look at one that doesn't look like that. Right, okay, so now if we are going to do elimination by addition on this system of equations in three variables, I have to look and think to myself, what's the best letter to eliminate? And I think it's the y. Now, I'm doing this right now, but you can set these up on a graphing calculator. A TI-83, a TI-84, it does have buttons to do with this. It's matrices, and we are going to be looking at matrices, you know, matrix. But it's part of the syllabus, but I'm not really going to do a video on it because it really is all about using your graphing calculator, and I can do it using this equation here to show you also the matrix version. So let's take a look at this. Remember, I'm going to get rid of the y's. I think that's the best one, but I'm going to only pick two of these, okay? So I'm going to pick these first two. So when I add them together, so remember that's equation 1, equation 2, equation 3. If I add these two together, x plus x is 2x. Can you see the y's cancel? 1z plus 2z is 3z, and 2 take away 1 is 1. There. I now have an equation in just two variables, not three. Right, I take a look at this again, go back to the first three equations and go, right, shall I pick? I picked equations 1 and 2 to add. Maybe I could pick 1 and 3, or 2 and 3, but to me, picking 2 and 3 looks the best because, again, the y's will cancel. Okay, so let's take a look at this. Again, add 2 and 3. 1x and 5x is 6x. Okay, the y's cancel. 2z and 1z is 3z, and -1, -2 is -3. There you go. I added equations 2 and 3, so I now have two equations in two variables instead of three equations in three variables. Right, I'm going to take this equation 1 down here, and I'm going to multiply it by -1. I'm just going to change the signs because I'll get this. See that -3z? Okay, so when I add them, the z's will cancel. I'll have 4x equals -4. Again, 6x take away 2x. So x equals -1. I'll put that up here. Well, I'll put it down here. X equals -1. Okay, there you go. Now, if x equals -1, let's plug it into one of these two equations. I'll plug it into here. Okay, so what's that? So 2 times -1 plus 3z equals 1. So that's -2 plus 3z equals 1. Add 2 to both sides. 3z equals 3. So z equals 1. Great. I now have z equals 1. I'm running out of space here. I'm going to erase that. So z equals 1. Okay. Right, now I've got these. I can plug both of these into any one of these three. It doesn't really matter. Maybe I'll pick the first one there. Right, x is -1. I don't know what y is. Z is 1. And that'll give me 2. So what's that? They cancel. Oh, y equals 2. Okay, so there you go. Those are my three answers. Okay. Now, what I'm going to do now is basically that's it. That is it for systems of equations in three variables. But I am going to show you, and leave the answers down there. Right, those three equations can be used in a matrix that looks like this. You just write the coefficients down. And here it is, look. 1, 1, 1, and it equals 2. 1, -1, 2, -1. Can you see? I am just looking at the coefficients. 5, 1, 1, negative 2. Now that's what a matrix looks like, okay? And if you were to put this into an app, a graphing calculator, it will come out with this. 1, 0, 0. I'll just bear with me. I'll show you this now. 0, 1, 0. 0, 0, 1. Now look, I've taken these three answers. Now can you see this? This means just the 1x with no y and no z equals negative 1. This is saying x equals negative 1, which is what we got, remember? This one, remember, this is just the y. This is saying y equals 2, remember? And this is saying the z equals 1, okay? So again, that last line there, where z just equals 1, is a bit like, remember, that line there, okay? So that is just you doing the matrix, but you've got to understand what it looks like, okay? You've got to get that pattern. It's like these diagonal ones, okay? You've got x, you've got y, and you've got z, and this last column is the answers, okay? But again, you can look at that for solving matrices using a graphing calculator.